Hello, this is the second video of a fourth vector series on equations of planes for OCR Pure Core Further Mathematics. And we will look at the equation of a plane using the normal to the plane. We saw in an earlier video that the scalar product of any two perpendicular vectors is 0. We can use this useful relationship to define a plane by making use of a vector that is perpendicular to the plane. This may look unusual to begin with, but it is very easy to work with once you get used to it. So every plane has a unique direction that is perpendicular to any line that can be drawn in the plane. And a vector that is perpendicular to the plane is called its normal vector, usually denoted by n. An equation for the plane can then be written if we know a point on the plane and its normal vector. If point A on the plane has position vector A, as seen here, and P is a general point on the plane with coordinates x, y, z, and position vector R, then the vectors r minus a and n must be perpendicular, as shown on the diagram. Hence the vector equation of a plane can be written using that scalar product, where r minus a dot n equals 0 because those are perpendicular, or r dot n equals p, where p equals a dot n, remembering that p will be a constant. So for a plane with position vector A and normal vector n, and a general point r equal to xi plus yj plus zk, which could be written as x, y, z as a vector, then the perpendicular vectors ar, taken in scalar product with n, equals 0. Rewriting this as r minus a dot n equals 0, and then taking across that a dot n, which will be a constant p. In this example, we're asked to find the scalar product form of the plane equation. This is the same as saying that we're looking for the equation of a plane using the normal to the plane. We are given that a is 1, 2, 0, and we're given that n is 2, 5, 3. By using the fact that this is the perpendicular to the plane. Using this equation then to find p, we can see that 1, 2, 0 scalar product with 2, 5, 3 will give us 2 plus 10 plus 0, or 12, and this is equal to p. Thus the equation of a plane is that r scalar product with 2, 5, 3 equals 12. So this is the scalar product form, which is also the equation using the normal to the plane. In this example, we're asked to find a vector equation of a plane containing the 3 points p, q, and t as given, in the form of r dot n equal to p. So if we can find two vectors in that plane from those 3 points, then we can use the vector product to find a vector that is perpendicular to both of them, i.e. the normal vector to the plane. You may remember the vector product was covered in an earlier video in the Vectors 3 series, and may be calculated by using your calculator or by formula. So let's find those two vectors on the planes. If we look at q minus p, that will give us minus 1, 1, minus 1. And likewise, t minus p will give minus 2, minus 1, 3. Then to find a vector which is perpendicular to both of those, we would use the vector product. So n will therefore be this vector product which will give us 2, 5 and 3. So we have found n, and all we now need to do is to establish that constant p. We could choose either p, q or t to form the scalar product with the normal vector. Here you can see we have chosen the point p to work out that small p, that constant, has a value of 12, hence giving us the vector equation of a plane as r scalar product with 2, 5, 3 equal to 12. Here you can see the plane P with its normal vector and the points P, Q and T in the plane. So you can see clearly that n is perpendicular to that plane now, and that the direction vectors on the plane are going to be PQ and PT. In the next video, we will look at the equation of a plane in Cartesian form.